Just like the street lights lit this town, like a fire in a blaze, gotta burn it down. Can't be afraid to leave this out. We got this far, don't know how. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we're gonna light it up tonight. We're gonna light it up tonight. We're gonna light it up just like the sunrise. We're gonna light it up now. Just like a spark that's breaking out. Can't make a stop, can't turn back now. We know that there's no room for doubt. No, we can't turn back now. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we're gonna light it up tonight. We're gonna light it up tonight. We're gonna light it up just like the sunrise. We're gonna light it up now.
Hello, everyone. Happy December. It is Monday, December 1st, here in the Western Hemisphere, and I am joined as ever by my wonderful colleagues and co-hosts, Ms. Lil, the Queen of Mermaids, and Ms. Kelly, the Queen of the Atheist part of Detroit.
Queen of all.
Annex the whole city. It'll be fine. Thank you all so much for joining us. So we're doing Advent this year because I've wanted to try this for a while, but to do Advent properly, you have to have a daily show. As it happens, we have one of those now. So that's what we're up to in the days leading up to the post-solstice holiday involving eggnog and shiny trees and whatnot. And don't get me wrong, I love the fucking shiny trees, just not the weird baby worship thing that goes along with it. So, to get us started, I got our hands on a little Advent calendar, but it's a science Advent calendar, which in this case means geology. And who doesn't love a little bit of geology? So let's open day number 1 and see what happens. And we got a pretty rock. And this pretty rock, there's a handy little chart so we can figure out which pretty rock it is. I need more light. My studio lights are not that bright. Let's see. It's vaguely bluish, and it's kind of square-ish. So I'm gonna say this one is the sodalite, which, like other forms of adventurine, this stone is a silicon dioxide mineral, and it's a member of the quartz family. So we have special quartz. It's like special K, but quartz, apparently. So yay! So we've got that's, and I've got there's one for every day. I know weekends are a little bit weird. The plan right now is on Mondays is we'll just open the 2 that we missed over the weekend as well as the one for that day. So Mondays will be extra rocky. But that's the silly thing. So our Bible quote for today, because Advent you're supposed to meditate on a Bible quote. We're going to begin our Advent at the beginning. Let there be light. We're talking about the Big Bang. One of the greatest secular accomplishments of our time is figuring out what the fuck is going on with our universe. Now, this is a multivariant story because it's not just understanding what our universe is doing now, but it's the story of one of the greatest accomplishments in science, in all of science ever. And it's also the story of our universe as it is, because uncovering this mystery literally reshaped our understanding of the universe in a way we didn't before. So there's 2 aspects to it. First of all, what the hell is the Big Bang Theory? Now, I've made a video about this before. What do we know? How do we know what we know? But it's kind of a long video because I put a lot into it. To summarize, we have 3, and this is a huge summary. We have 3 basic pillars of information the Big Bang is based on as a theory, and theory again being a model using established facts, right? So we've got 3 things. The first is the galaxies appear to be racing the fuck away from each other on the biggest scales. The universe is expanding. All the galaxies are in motion. They're all going away. Either Earth made a big old stinky and everybody's trying to leave the elevator as quickly as they can, or the universe is expanding. And it could honestly be either one. It's hard to say. So the second piece of information we have is the elements, right? The universe is almost entirely helium and hydrogen. What explains this? Well, there's a few different ways to explain it, but the universe condensing out of energy is probably what there's really only 2 candidates, right? There's the universe condensing out of energy, or there's energy continuously condensing out of empty space. And that's where we got steady state model, which was the only serious rival to Big Bang for a very long time. So we had both of these options. We both could explain the elemental distribution and even the oddball elements, right? Like it was a steady state guy, Fred Hoyle. Steady state was his jam, who figured out stellar nucleosynthesis that gave us the distribution of most of the other elements besides the hydrogen and helium. So technically, the distribution of elements, Big Bang stole from steady state, and that makes steady state like the stronger theory. But then we come to the third thing, the cosmic microwave background radiation. This is a weird thing because a lot of people are like, oh, cool, there's the signal in the sky that's the red shifted light from the last scattering following the Big Bang. It's not from the Big Bang. It's like 300,000 years after, but that's not important. It's the earliest light we can see. We cannot see light past it. And that's a falsifiable prediction, by the way. If you can detect light older than the CMB, you will falsify the Big Bang Theory because it shouldn't be possible for there to be light older than that light. But I digress. The point is, it is a real scientific theory with falsification criteria. But it's a really cool thing because it's not just any old light. It's not just any old signal. It's omnidirectional. It's the only source we have ever found that, unlike a star, which is a point of light, or a radio tower, which is a point source of electromagnetic emissions, it's everywhere. It's coming from everywhere at the same time in equal strength and nearly identical wavelength. The variation is very, very small. We needed to build really specialized instruments to find any differences in the signal. It's so fucking cool. And that was a prediction of Big Bang. Gamow and Alpher predicted it, that if this is what happens, if the Big Bang is what really happened, then we will find this last scattering light. And then we found it. It was a certified, verified prediction. Now, we didn't know what it was the first time we found it, and that's a whole story in and of itself, but we did find it. And so that's basically it, is the three main proofs. Now, there's other stuff too. The thing that happened to convince me was the light curves of type 1a supernova in distant galaxies, but that's awfully technical. Suffice it to say, type 1a supernova are special because they have a standard brightness. They always have a certain brightness, and the brightness fades along a time period. It's a brightness curve, right? As the longer it is, the more it fades, but it's always identical. That's what makes it a type 1a supernova. In very, very distant galaxies, that diminishing brightness curve stretches out because it's moving at such high velocity that we're seeing a Lorentz transformation that is dilating the time itself. Because it's moving so fast, it seems like time is running slower. And that's proof of relativity. And that's a thing that steady state just cannot handle. It just does not work in any other model. So that's what brought me on board with Big Bang, because I was a Big Bang denier for a long time. I was a young earther of cosmology. Oh, good. Now I'm echoing. Why am I echoing? Let's see. I think Kelly's already muted. Am I? Well, now I'm not echoing. Okay.
No.
That was weird. I blame Obama. But I also blame Lil Ball Trades for sending us a super chat for $5. Thank you, Lil. And Lil says, Christians have the Big Bang Theory too. God said it, then bang, it happened. All hail the ex nihilo. It's do hail nil. See, the Christians, they're not really Christians. They're all praising Nil, the great not God and creator God. Where else do creator gods come from? They need a creator. So we've got Nil, the creator, the great not God, but creator of creator gods. Praise Nil. And incidentally, yes, there it is. If you want to keep those nasty blood gods away, you can get a Nil scented soy candle to drive away the stinky blood gods. If they're troubling you, that's a thing you can actually get. There it is in the Ember store. Yahweh away, Nil scented soy candle. With its Nil scent, will free your space from all the dark, nasty, evil demon gods and things. We got products, folks.
Speaking of product, and on a slight tangent, even though like we're doing Advent, so one thing me and my mom have done for as long as I can remember is we'll get each other a stocking stuffer every day of the month all the way up until Christmas, but it's like something little, and we usually like collect them throughout the year. Anyway, this is what she got me this morning.
Oh, it's a mermaid in a shell, a redheaded mermaid,
yeah,
a ginger mermaid.
Yeah. I know it doesn't look like it right now, but if you see my hair out in the sun, I've got a ton of red in it.
Interesting.
So, but it only shows up in the sun.
That's a neat trick about, okay, that gets into wavelengths and all sorts of stuff. And we'll get into some of that as we go on, but it's wild. TLDR. As many of you know, I'm half Irish and half Scottish, as well as half Welsh. And my children have inherited many of my genes because they're much more, they're dominant genes over the weakling English genes that their other parent had. So yeah, even though I myself am not a redhead, they've all got bits of it, but my son in particular, he's like, you know how there's like strawberry blonde where it's like your redhead, but it's also light. It's very blonde colored as opposed to like copper top. My son is like dark Irish. It's red, but it's dark red, you know? It's like strawberry blonde, but the other direction from straight up red. It's very curious.
Yeah, on my dad's side, there was a lot of gingers and a lot of what they call sandy browns. It was like a brown, but it's like real light brown. It looks almost blonde. But my mom's has the black hair, so I think mom, you know. But yeah, but it was either the gingers or sandy brown on my dad's side.
Yeah, so, but mermaids, being ginger makes sense because mermaids have no soul, because that's the story. And so they're luring sailors to their death to get their souls, right?
Yeah,
That's how
makes
that
sense
works.
to me.
Maybe that's why I'm Queen of Mermaids.
See,
And my name
there's a
happens to be.
difference between being a soulless atheist and a soul stealing monster of the deep, you know?
I mean, yeah, it fits because being a soul stealing monster of the deep, and then my name also being Lilith, which is, are demons mermaids?
Can't rule it out. Are they allergic to iron?
I don't think so.
I can't
maybe
imagine
not.
holy water would have any effect on them.
Okay, yeah, mermaids or demons. There we go. I'm even wearing my mermaid skeleton shirt.
All right.
I just realized that. I was like, oh, holy crap. I've got so many shirts with mermaids on them. It's absurd.
Mermaids have fish souls. That's what the affiliate said.
Now, if you subscribe to the idea, so I kind of like the Aristotelian version of souls, which is the soul is the animating force. It's the difference between being alive and dead. It's the reason you can do this. You can use the power of your mind to control blobs of matter. That's a soul. That's what a soul is. And under that hypothesis, every animal has a soul. It may not have a brain capable of consciousness, but it has a soul to be its animating force.
Some plants
If that's
too.
true, then mermaids are half fish. They would have, even though they're ginger, they would at least have half a soul. And perhaps that it's not like being soulless, being an atheist. We can deal with that. We can move just fine through the world. But having half a soul, that puts you in a precarious position where you like crave completion. You need the other half of your soul. But every soul you take, every life you end and absorb their soul, it's not compatible with the half soul you have.
True.
And as Theo points out, we're all bony fish.
Yes, we are.
Law of monophily. We are still fish. We're very, very mutated fish.
It was
Kyle says mermaids are lighter than a duck, which means they're made of wood.
Hey, Kyle.
Oh goodness. Yeah,
it's one of those things that I will never forget. So I had homeschooled my youngest for a year and a half, and I was teaching him biology and all this, and I basically went through of how we are all fish, and like the look of like, what the hell are you talking about? You're crazy, all the way to, oh, holy crap, that is so cool. Like the look on his face as I was going through this lesson was like the coolest thing ever. Especially when they realize like the stories of how everything actually happened is way cooler than the fairy tales. Like,
right. That's the thing that I one of my favorite conversations with ever on all of YouTube's was, I forget which channel I was on, but Stephanie Helms and I were talking about the idea of the numinous, right? This sense of greatness and sacredness and holiness about the universe and reality and so forth, and how these stories that people like to worship, that just take all this wonderful stuff, the dust of creation, the star stuff that comprises our bodies and makes our lives possible, the eons of planetary formation, the billions of years of evolution, the millions of years of our ancestors struggling and striving and adapting and building and yearning and dreaming and learning, and it takes all of it and just goes, God did it.
Yeah.
It's so diminishing of the true majesty of reality.
Yeah. And it's one of those things that I'll give a little bit of grace to the people who are like, well, God started it all, but then everything just happened the way it did. Like, God started the Big Bang and then everything. And it's like, okay, Like, I obviously don't agree with that, but whatever. I'm not going to argue too much because we don't know what caused the Big Bang. We don't know yet what caused it.
Well,
but when people say, I don't know how the Earth got here, so God did it, that doesn't work. Like, it just doesn't work to anybody who can even logic like a third grader. It just doesn't work that way.
Sapphire says, and by the way, hello everyone. Thank you all for joining us. If you're new, this is what we do here. We talk science stuff and other unrelated things because people come here for the tangents. But so subscribe. And if you're watching in the future, subscribe and ring the notification bell because you could join us in a live chat next time. We'd love to see you. Sapphire says, evolution is so cool. Phylogeny is why we have walking fish and boneless dogs. Now, if you consider that every modern tetrapod is a fish, we are fish, but so are the beefy cows, and so are the bacon pigs, and so on and so forth. Then we're all committing cannibalism all the time. Everything we eat is a fish, unless you're into, that veggie stuff, whatever. I actually love fucking veggie. Salad is so... I digress. The point is, we're all cannibals.
Yeah, you can eat shellfish. Well, no, because if you go back even further, damn it. Yeah, we're all cannibals.
Shellfish is fish too. Yeah. I mean, well, if you go with the evolutionist hypothesis, then we all come from Luca, and so we're all related.
Mm-hmm.
It's so weird that nobody's worshiping Luca, because that's like a thing we can demonstrate. Like, we don't have a fossil of it. Duh, it's one organism, but whatever. We can demonstrate scientifically, mathematically, genetically, through many lines of evidence that it definitely existed. So here's the thing, that's why nobody worships it, because we know for sure it existed. People want to worship things that don't exist, because then they can't ever tell you you're doing things wrong. It's fucking wild. But I don't get with the God of the Gaps business. Like, even if you want to allow them to stick God in that one final gap, it's not that much of a gap and it doesn't make any fucking sense.
Yeah, but it's just one of those things that it's not worth my time to argue with them about the one thing that we can't readily disprove. So
yeah, I just, in that sense, I just have more, if you know it's not true, but can more be realistic, thinking it might be a multi-God thing. You're like, why do you think only one God made everything? But at least with this story, they didn't know. Now we know why things happen. But for them to think that it was different beings in the sky doing these things is more understandable than saying it was one guy did everything. Like he just did everything by himself. Didn't need no help or nothing.
Yeah, it's just clear toddler level storytelling. It's like, we look at the God of the Eden story where he's wandering around. He's like, no, don't touch the fruit. But also, I can't find Adam and Eve. Where are they hiding? This is not the same God who hovered over the waters and caused things to be with a word, right? That was the ancients came across this other group of people who had a bunch of gods, but one God who created with the power of his words. And they were like, yoink, our God can do that now. Our God's better than your God because he can do everything. It's exactly Moses versus the Pharaoh's priests. That's exactly the thing. Is my God can do everything your God can do, but bigger. Yeah. It's the same bag of tricks. It's clearly cut and paste. Why is it that God can't do things that humans at the time the stories were revealed couldn't imagine? Turn water into blood? Sure. End a plague? Nope. God's powers are very weirdly limited, and it seems to just exactly line up with the limits of human imagination. Strangely enough. I digress, though. But okay, trying to get back on topic. Hypatia says pre-existing particles abruptly gaining mass, creating an inflation, pushing expansion, is remarkably close to the best hypothesis that I currently understand, which, as we talked about earlier, particles seem to have condensed out of energy. And that's thanks to E equals mc squared. We know that if you accelerate a particle hard enough, you give it enough energy, it will look like an electromagnetic wave until you slow it back down again. We can also create electromagnetic waves by taking particles and antiparticles and smashing them together. It's called annihilation. The mass is completely eradicated and it produces two identical opposite photons going in opposite directions. It's fucking neat. But if you take those same photons or equivalent photons and you shoot them directly at each other, and this is still being tested. We don't know if it has to be definitely head-on. It's just easiest to do particle colliders with head-on collisions, but whatever. You collide these identical wavelengths, the photons will be disrupted, and a particle-antiparticle pair will fall out into reality. Often they'll immediately re-annihilate and send photons off in other directions. But if you can use magnetic fields to snag them and pull them apart fast enough, you'll create matter and antimatter out of photons. It's fucking nifty. And so this is the basic hypothesis of what may have triggered the inflationary era of the Big Bang, is because all this energy was running around in this way too dense a state to form particles. When the photons, the energy, very high energy, are smashing into each other, they keep trying to form particles, but they can't. So they create disturbances that effectively, it's little bursts of mass, and mass distorts space. We know this from general relativity. So this mass keeps popping in and out in effectively no time, because time is a function of space-time. You need space to have time. That's a whole thing we'll get into later, probably. So we've got these bubbles of mass distorting space that are blasting outward from this point that's only a point. It's again, this is just a hypothesis at this point. We cannot test anything close to this far back. But the model is very compelling because it makes the Big Bang happening an inevitability, because you can't not have this happen in the early singularity-ish field that is currently described by our mathematics. It is a thing that must happen, and when it happens, it causes ridiculous expansion of space. It's fucking cool shit.
Yeah, it's awesome. Like, I've been watching, I've been keeping an eye on the papers. I've been coming out on all the hypothesis on it for the last couple of years, and there's some really, really interesting stuff coming out, which is really cool.
Yeah. So yeah, it is, and Hypatia says it's an inevitable consequence. So TLDR, if we're right about the initial conditions, and again, hypothesis, not actually part of the model, just a hypothesis. But if we are right, then not only is there no need for a God, there's no possibility of a God. Because the universe forming the way the universe formed is the inevitable consequence of the initial conditions. You might say the God created the initial conditions, but that doesn't make any fucking sense either. But since when is things making sense matter to theists?
Never.
Oh, goodness. Kyle is excited because new data suggests dark energy may be weakening and the expansion may be slowing, which indicates a big crunch scenario is back on the table. So we may end up with a rebounding universe. Now, I have thoughts about that too, but that is the other end of the direction we're looking at today. Today, we're doing the Big Bang. Let there be light. How did things get started? Now, like I said in the intro, there's more to it than just what we understand today. There's how we got to understand where we are today. And to me, this is the most fascinating Christmas story. Maybe I'm a weirdo with this, but c'est la vie. So I've got two things for us. The first is an article that describes the discovery of a lot of this shit. And then if we get to it, there's a video that describes our current understanding of the first moments of the universe. Asterisk. It's a YouTube video, so it's not going to get everything absolutely right. But it's, from what I've seen of it, it's pretty fair. And we can correct it as we go along. But I do want to bring up our article because it's so fucking cool. So this is from EBSCO, and it's telling the story of well, I'll just tell you the story. Stars were not a very satisfactory study object for early astronomers. In contrast to the planets, they did not appear to show motion relative to one another and appeared as mere points of light when viewed through a telescope. The snowy band known as the Milky Way was an exception. Ancient peoples had seen that as a reflection of their own worlds. But in the mid-18th century, investigators assumed that this nebulous glow was produced by faint, distant stars. A different kind of nebulous glow was noted by Immanuel Kant, yes, the philosopher, because philosophers also often dabbled in the natural sciences, who suggested that these so-called nebulous stars were actually other universes outside of the Milky Way. And this was a weird idea for a long time, but he was kind of right. Pierre Laplace, yes, that Laplace, the one who presented his model of how the world works to Napoleon, and Napoleon said, "Where's God in your model?" And Laplace said, "We have no need for that hypothesis." That Laplace, he suggested that some kind of nebulous material might have been the formative material for Earth's solar system. But William Herschel, early astronomer, very famous, one of the first astronomers to concentrate on stellar astronomy, who found many of the nebulous clouds could actually be resolved into individual stars. With a big enough telescope, you can look at these nebulae and see individual stars. It's not protoplanets. There's a fuck ton of stars in these things. So Herschel concluded that if sufficiently powerful telescopes were ever available, scientists could see that all the nebulous clouds are in fact star systems. Later, however, he recognized that this hypothesis would not explain all the phenomena, reversed himself, and suggested what became known as the nebular hypothesis. He proposed that the unresolvable nebulas were the parents of the stars. First came the nebulous matter, then the nebulas, and finally stars started forming out of the nebulas. After enjoying a brief period of acceptance, the hypothesis fell into disrepute after William Parsons, 3rd Earl of Rosse, reported to the British Association for the Advancement of Science in 1844 that he had constructed a reflecting telescope that could resolve the apparently formless nebular material into discrete stars. He discovered that certain nebulae had spiral structures and was able to distinguish individual stars in several of these spirals that Herschel's less powerful instrument could not. Even with Parsons' telescope, however, all the nebulas could not be resolved. There were still fuzzy globs out there. So we're learning, but we don't know what the fuck is going on yet. Advances in photographic techniques and the development of spectroscopy, which is the analysis of light spectra. You probably learned about this in school, how you can take a prism and split light into a spectrum. You may have learned in chemistry that when you run that light through something, whatever it's made of will leave lines in the spectrum. These are absorption lines. The matter, the specific matter the light is passing through, will absorb in very specific discrete wavelengths. It works the other way too. When you have a glowing source, those are emission lines. But I digress. The point is that's what spectroscopy is getting the chemical analysis of what a light is passing through by looking at the lines that are missing in the spectrum and comparing them to known chemical IDs. And this is vital for what comes later. So we've developed spectroscopy. At the end of the 19th century, it made possible a more detailed examination of Parsons' spiral nebulas. Some astronomers were convinced that they were nebulas within our galaxy, relatively small nearby objects, something like globular clusters, but a different formation. Others thought they might represent different universes, large and very distant. Because remember, before we discovered there were other galaxies, we thought the universe was the Milky Way. That was it. And they were kind of not wrong, but that's for later. Although the idea of island universes, worlds similar to our galaxy. Now, I should pause here to explain. Worlds. The term world, we today think of as being synonymous with planet. But at the time, and going back to ancient times, world meant the entirety of reality you were aware of. If you were, say, an ancient living in ancient Persia, and a big flood came and flooded all of Persia, you would think the whole world had flooded, because world is the entirety of what you're aware of. Later on, world would come to mean all of Europe and Asia and Africa and some of the Pacific Islands and so forth. Like, world keeps expanding as we learn more stuff. Today we think about planets, but in the middle of the 1800s, because we become aware of our solar system, our arm of the Milky Way, the fact that we were in a galaxy. So to us at that time, world meant galaxy. It was the totality of our cosmos. That's what world meant. It changed later when we had to redefine what the fuck a universe was. So, island universes had been proposed earlier on as philosophical but not observed grounds, and Kant in the 18th century had suggested that the spiral nebula might represent such island universes. The question was not completely resolved until 1935. And here's that story. Vesto Melvin Slifer published observations in 1912 using improved spectrographic tools, the instruments used to disperse the spectra and find the emission lines and absorption lines and such. And that provided data vital to determining whether the spirals were part of the Milky Way galaxy or part of distant, hitherto unknown galactic bodies. Now, it says worlds, but I'm saying galaxies I'm translating for the present folk. Slifer responded to requests by Percival Lowell to join the staff of the Lowell Observatory in Flagstaff, Arizona. His skill at perfecting spectroscopic equipment, his meticulous care in obtaining observations, and his cautious interpretations made it possible for him to make many important fundamental discoveries. Using spectroscopic techniques, Slifer measured the rotational period of Mars, of Venus, of Jupiter, of Saturn, and indeed of Uranus, and identified bands on Uranus. People need to wash better. I digress. Identified bands in the spectra of Jupiter and Saturn as being caused by ammonia and methanol, and found evidence that interstellar space contained both dust and gas. This is no meager accomplishment, because for a very long time there was another thing philosophers had been talking about called Olber's paradox. If indeed the universe is eternal, as seems to be the case, then how is it that every line of sight doesn't end on the surface of a star? If the universe has been around forever, then there should be a star at some distance in every possible direction. So why is the night sky dark with spots instead of light? It turns out the solution is space is full of dust and shit. There is shit in space. It's not completely empty. And it doesn't need to have much, because when you're dealing with hundreds, thousands, millions of light years, all you need is one atom to get between you and a photon, and that photon is blocked, you know? So
like,
you don't need a lot of dust.
Just to kind of hammer that point home, we can't see. So, like, the video, the picture that you saw, or the image rather, that you saw of Sagittarius A star that came out several years ago, they had to do that in infrared and microwave, because you can't see it in visible light. It's completely blocked by dust. Like, you can't see anything in visible light. So you have to use infrared, microwave, and X-ray to be able to see the center of the galaxy.
And that's just a weird quirk of our own evolution, owing to the nature of our star, right? Like, we see invisible light because that's the strongest frequency our star produces. So that's what we've evolved to see. If our star were different, we might see in X-rays. We might see in infrared. We might see in whatever. It all depends on the output of your star, because that's what drives your evolution. And if we had evolved to see in infrared, if our star were, a little cooler, and infrared, what we call infrared, would have been the peak output wavelength, then we would have evolved to see in infrared. We wouldn't know there was dust in space, because the infrared punches right through the dust. But it's just a quirk of our evolution. It makes me wonder, what else aren't we seeing because of the weird quirks of the way we perceive things?
Yeah.
It's pretty neat.
Mm-hmm.
So anyhow, yes, space contains both gas and dust. So Slifer, he made his most profound contribution when he turned his attention with his magical spectrograph to the elusive spiral nebulae. Slifer's part in early 20th century astronomical controversy over the location of the spirals was an indirect one. Using an improved camera, he investigated not only the spectra of the spirals, but using the spectra was able to calculate their velocities, the same trick he used to get the rotation of Mars and Jupiter. Because when you have your emission lines, you know what they look like stationary here on Earth. And we also know from Doppler's law that if you move at a significant fraction of speed, the speed of light specifically, you will move those emission lines or those absorption lines in the spectra. So if like hydrogen makes a line here and your source is moving away from you at a significant fraction of the speed of light, then that line will shift redwards. And we can tell that it's a hydrogen line because of what it is, but we can use the shift to calculate how fast it's moving. And the same thing if it shifts bluewards, except it's coming towards you. That's from Doppler's law. Already known math, easy stuff. You need very precise measurements to do it, and you need to identify specifically which elements you're looking at so you can get the exact offset. But from there, it's just basic algebra. So he's aiming his spectrographs at these nebulae, and he's finding that their emission lines are very shifted. And he's like, holy shit, these things are moving. The velocities are crazy. So beginning his work on Andromeda, he determined that the spirals had exceptionally large radial velocities. He found, quote, the great Andromeda spiral had the exceptional velocity of approximately 300 kilometers per second. That is by far the greatest velocity of anything ever recorded. At that velocity, if it were close to us, we would be having a very bad day by now. It's stupidly fast. So radial velocities, those measured only along line of sight. And this is an important note. Using redshift, we can only calculate velocity relative to us, what's approaching us or what's moving away from us. We don't have anything that tells us whether it's moving sideways relative to us. Like people often talk about how Andromeda is coming towards us and will collide with us in 4 billion years, give or take. Yes and no, it is coming towards us, but we don't know about its sidereal motion. We could easily zip past each other because if it's going this way, perpendicular to us, and we're going this way, perpendicular to it, we could just zip right past each other. We don't know. We can only tell what's going towards each other. So that's pretty neat. I should have marked where the hell I was before I got off on my tangent there. Yeah, radial velocities, measured only along line of sight, can either be approaching or receding. For an object moving towards a wave source, the wave frequency appears to increase and become shorter. But moving away from the source, the waves appear less frequent and the wavelength longer. This phenomenon, called the Doppler shift, or the shift in light or sound caused by the relative motion of the source and receiver, relative motion is all we ever have to work with, can be illustrated by sound waves. When a truck approaches with its horn blasting, its pitch is higher than when the truck is at rest, and as it passes, the pitch is unshifted. Then as it moves away, the horn produces a lower pitch. It's still blowing the same note, but you hear it. I mean, you hear it from tires on a car approaching. Bzzz, and then it passes and it goes bzzz, we've all heard that. That's what that is. That's the Doppler effect. It's very pronounced in sound, but the same thing happens with light. So yeah, the same phenomenon occurs with light waves. Slifer measured this with his spectrograph. The Doppler shift produced by the radial velocity was measured by the change in the wavelength of the lines in the spectrum, the emission or absorption lines, are shifted to the blue end in the case of Andromeda for the spectrum of an approaching object, and towards the red end for ones that are receding. After his initial work on the Andromeda Nebula, Slipher observed other spirals. When he published his results in 1914, remember, this was the same time Einstein was publishing relativity, right? Like special relativity was 1905, general relativity was, I think, 1913, but don't quote me on it. But they were all the same era. So. Yeah. So like all this stuff, these advances in cosmic knowledge, it's all coming out at the same time. And granted, it's all driven by similar advances in technology. Like Slipher's discoveries are because of better telescopes, better cameras, better spectrographic equipment, etc. Like these things, it's not necessarily that these people are themselves geniuses. Their ability to use the stuff makes them the best in their field. But all of this depends on advances in technology that we all share, and it's only the rich assholes who have access to it. But never mind that for now. We'll see the means of production another day. So, when he published in 1914, he'd obtained Doppler shifts for 14 different nebulae, all showing large radial velocities. Although he was given a standing ovation when he announced his discovery at a 1914 meeting of the American Astronomical Society, 1 gold medals for Paris Academy, Royal Astronomical Society, the Astronomical Society of the Pacific. The interpretation of his findings became part of the island universe controversy. Some astronomers, such as Ejnar Hertzsprung, Hertzsprung, we'll go with that, were convinced that as the spirals had such remarkably large radial velocities, they couldn't be part of the Milky Way. They're moving too fast. They can't be part of our galaxy. Slipher, in a lecture to the American Philosophical Society in April 1917, recognized that his observations support the hypothesis that spiral nebulas are very stupidly distant. But it's indirect. It supports a hypothesis, but it doesn't demonstrate it. So we're still stuck for a minute. Other astronomers would not be convinced until the actual distances of the spirals could be computed. Herbert Daust-Curtis, one of the first to suggest a much greater distance for the spirals, immediately accepted the implications of Slipher's idea. He had already reached the conclusion the Andromeda Nebula was 500,000 light years away, and Slipher's data provided support. Worth noting, we didn't have a precise measurement of the Milky Way at the time, but 100,000 light years, give or take, was a reasonable estimate. So for something to be more than 5 times further away than the size of the entire universe, that was a problem for the cosmological models of the time.
Oh, yeah.
Which is neat. So Curtis publicly debated the point with Harlow Shapley, who, relying on measurements by Adrian van Manen, insisted that the spiral nebulas were merely nearby nebulous objects. We must be wrong about the velocity. There must be something else interfering with the Doppler shift, with the light. And this is a thing that stays constant right up through the 1960s. This is what drove Hoyle to keep remodulating his steady state idea. It can't be the universe is bigger than we thought. There must be something wrong with the light that we don't yet understand. And in fairness, it's good to look. It's good to check. It's good to be skeptical and say, what other explanations could there be? Let's test and rule those out to make sure we're not missing something obvious.
Yeah. I mean, that's one of the super interesting things that I find with science is when we discover something that we didn't expect. Like right now with cosmology, it's all going on with the Hubble constant because there's 2 different measurements and blah, blah, blah. But what's super interesting is if you look back in the history on things where something doesn't match up where it should, about half the time it's because we measured wrong. About half the time it's because our theory was wrong. And so it's one of those things that you can't look at it and say, like, well, the measurement's probably wrong, blah, blah, blah. It's like, it's always kind of a crapshoot on which one it is, because it's almost 50-50 on whether we're wrong or is the measurement wrong. And it's one thing I love about scientists, especially the scientists I know, if they come up with a hypothesis, they absolutely love proving themselves wrong, because that means that there's still more out there to figure out. Like, they love being proven wrong. They much
I say that all the time.
Yeah.
I love being wrong because it means I learn more.
Yeah. And, like, learning stuff is, like, there's a reason why I absolutely loved being a college student and why I loved getting my degrees, is because it's just like, I like to learn stuff. I still do on a regular basis. I basically challenge myself to, I want to learn at least one new thing every day.
Well, we can help with that. Deviant Outcast says it's pronounced Einar. It's just the Danish or Norwegian spelling, and the last name is German. Hertzsprung. So it's Einar Hertzsprung. So yeah, we've learned a thing. Congratulations. We can all go back to bed. Right, and it says it's just a theory, a physics theory. We are on YouTube. It's inescapable. It's fine.
I hate that. That's like my biggest pet peeve. That's my biggest pet peeve, when they're like, well, it's just a theory. No, that's not a theory. That's not what a theory is.
We could have brought that up on the pet peeve episode on Job and Drugs. Did you? Okay.
I did.
Yeah, because I'm like, that one's fucking valid. It's so rude. So rude. Like, it's just the banner of ignorance. But I digress. After 1925, Van Manen's measurements were less influential, for Slifer's work on the direction of rotation of the spirals directly contradicted Van Manen's conclusions. Remember, Slifer got started by measuring the rotation of things. He can do more than radial velocity. He can tell if shit's spinning the same way, because if shit's spinning towards you, blue shift. If it's spinning away from you, red shift. So this side of Mars is blue and this side of Mars is red. So it's spinning this way. And then we notice the big fucking mountain, Olympus Mons. When it comes over the horizon, we can measure how long it takes. And ta-da, we have the rotation of Mars. Magic. Jupiter's a little harder because it's a big old gas ball. So the gas moves around, but details. So he measures the rotation of things. So he's measuring the fucking spirals. So he's working on that. At the same time, Edwin Powell takes another piece of observation, which is that certain kinds of Cepheid variable stars have certain periods. Right? Like they vary on a certain, like, for example, a star that's like bright for one day and then dim for one day, and then bright for one day and then dim for one day. Not only do we know which type of variable it is based on that period, but we know its absolute brightness from local stars that are Cepheid variables. We know the period is directly linked to how bright it is. So you can observe a distant Cepheid variable, measure its period, and know how bright it's supposed to be. And based on the difference between the actual observed brightness and its known intrinsic brightness, you can calculate how fucking far away it is. It's a neat trick. So Hubble's using this math. He's observing, because he's got this big fucking telescope over at the Mount Wilson Observatory. He's observing in these nebula specific stars. He's finding Cepheid variables. He's measuring their brightness, and he's doing the math and saying these things are really fucking far away. Holy shit, you guys.
Yeah.
So he does his measurement. The demonstration from the Cepheid variables in the spirals indicates that they must be remote. And by remote, we mean island universes, baby. So, nevertheless, given that Van Manen's measurements seemed to represent observational facts, they were difficult to abandon even with contradictory data. Van Manen's results eventually were ignored, not so much because they were proved wrong, but because new evidence seemed to prove incontrovertibly that the spirals were galaxies in their own right. Hubble's 1935 paper in the Astrophysical Journal finally brought the controversy over the distance of the spirals to closure. Now, the reason Slifer gets forgotten is because Hubble took the existing measurements from Slifer and incorporated them with his own measurements of distance. He said, Slifer's telling us how fast they're moving, and I'm telling you how distant they are. And if we put those on a graph together, you get Hubble's law. You get the more distant it is, the faster it's moving away. And at the same time, Einstein has put out this mathematical theory of the cosmos that shows that any finite cosmos, any limited amount of universe, must be either expanding or contracting. And they went, oh, look, the universe is clearly expanding. And here's this math that we've tested out by measuring solar eclipses and shit, clocks, all sorts of things, that shows the universe must be expanding or contracting. And here we have observations showing it's expanding. Ta-da! The expanding universe of general fucking relativity, which we now call the Big Bang, also thanks to Hoyle, because he hated the idea. He wanted the universe to be eternal, and so he called it the stupidest little kid name he could think of, and it stuck.
The one that annoys me about the Big Bang, and it's been a complaint of mine too from astronomers and astrophysicists on how they name things. I get that they name things simply, but the Big Bang also, considering they kind of adopted it, gives this impression that there was an explosion somewhere. And it's just like, no. I mean, at least with DNA, when you hear the full name of it, like, you have to explain what that is, because nobody's going to know what that is. But the Big Bang, you say the Big Bang, everybody thinks they know what you mean, when most of them don't.
Well, the fun thing, though, famously, sound doesn't move through space because sound requires matter to reverberate through. However, at the last scattering, that moment when the CMB was first emitted across the entire universe, when the universe went from so dense, photons couldn't penetrate, to suddenly being permeable, and photons could flow freely. That seemed to happen effectively at the same instant throughout the entire fucking universe, which is really cool. That implies a phase change sort of thing along the lines of energy density. Like when you've got super cooled water and you tap the jug and you've destabilized it and the whole thing freezes virtually instantly. That sort of effect.
Yeah.
Because the preceding state was so dense that light could not penetrate. We effectively had a cosmos full of matter touching each other. So, at the moment of the last scattering, you have a concussion event, a phase change, whipping through the whole cosmos nearly instantly, and it's a matter-to-matter concussion. It's a blast wave. You did. It was 300,000 years after inflation, give or take. But there was definitely an audible bang. And that's pretty neat.
Yeah. And it's like one of the most mind-blowing fact that my son said that he learned about the Big Bang is that the cosmic microwave background, which is now well into the microwave range, started out to be orange. And now it's microwave. Like, that's how long those wavelengths have gotten stretched
so
out.
this is one of the things, as you know, I was a Big Bang denier. I worked with Dr. Halton Arp at the Max Planck Institute in Germany, remotely, obviously, but we were working on trying to resurrect the hypothesis of tired light. And part of my studies was I took the actual observational data from the cosmic microwave background radiation and tried to reverse the effects of the redshift to see what it would have looked like at the time it was emitted. And, you know, this is a thing that other scientists have arrived at from other directions. But to my knowledge, I'm the first one who tried to reverse the stretching effect of the redshift. It's fucking orange. It comes out at just slightly cooler than our star. That was the surface of the whole cosmos. Now, that's a very hot cosmos. That will still kill you fucking dead. But the fact that it just happens to fall, remember what we were just talking about the weirdness of our visible spectrum, and the fact that it falls so damn close to the middle of our native visible spectrum is just weird.
Yeah. It's weird, but it's so damn cool, too. I mean, like I said before, it's like, I don't get I will never understand why people prefer the creation myths over the actual story of how we got here, because I think the actual story is just way cooler, even on just like a storytelling basis, and it has the benefit of being true.
I start thinking it's a form of Stockholm syndrome. Not that severe, but it's control. And you've been taught this is how it's supposed to be. Because I mean, I was raised that way to believe whatever the Bible says is true.
Yeah. Like, I literally had an argument with my mom probably about a year ago or so. And I was like, and I said something like, yeah, we're animals. And she looked at me like, huh? And I'm like, oh my God, she's not doing this. And anyway, so we went through the whole thing, and I've seen Forrest Valkai do this. And I was like, okay, are we mammals? She's like, well, yeah. I'm like, then we're animals, because mammals are a type of animal.
Thank you.
And the interesting thing is, like, I've seen a lot of her, I don't know if she's completely let go of them, but a lot of her irrational beliefs about it, which more irrational, let's put it that way, the more irrational beliefs, religious beliefs she has, I've seen those soften over the years. Which, you know what? She's my mom. I'll take it. And she's not constantly coming down on me. So
we don't come from no monkeys.
I had a friend who believed in every conspiracy theory, and she was fun to argue with. Because every conspiracy theory, she'd be like, we never went to the moon. I'm like, we have pictures of the fucking moon landing sites. Oh, goodness.
That was just a green screen. I think I believed that for a minute, though.
She was like, I didn't evolve from no monkey. I'm like, you're right. You didn't evolve.
Uh-huh.
You're still chimpanzeeing around up in here. You're like, rah, rah, rah.
But then when you start looking at the other great apes, you can see how we connected, how we, we have verbal language through this form, but they have communities and societies. And
one of the super interesting things, and I want to say it's chromosome 2, I could be wrong, so don't quote me on this, but between chimpanzees and us, since we shared a common ancestor, at some point way back in our lineage, 2 of our chromosomes fused together. Theirs didn't. So we have 46, they have 48.
Yeah.
And the super interesting thing about it is, because from what I remember, the type of mutation that is for those 2 to fuse together happened in one person. So we are all descendants of that one creature that had that fusion event, which is just unbelievable.
It only takes one person having a mutation to spread it throughout an entire population.
That's what they say. Like the mutations of redheads, blondes.
Yeah.
They all came from a single mutation.
Mm-hmm. The ability to drink milk as an adult without having lactose intolerance. I mean, that's a single point mutation.
Gene.
Yeah. And there's, I think it's up to 30% of adults now have that mutation. I have that mutation. I can sit here and drink milk all day long, and it doesn't bother me at all.
I used to be that way, but I got a certain age, it just changed. Because I'm like, wait, what is going on with me? And I'm like,
there's 2 ways to maintain it. One is to have the gene so you never develop the intolerance. The other is to never stop having dairy products. Because a lot of people do have the gene to develop the intolerance, but it comes into effect when your guts stop processing dairy. So if you grow up where you're having glasses of milk every day, you're eating cheese regularly, and so on and so forth, you will never lose the ability to, well, I won't say never, because there's everything you can think of happens in biology, but you're more likely to hang on to it. But if you then go through a gap of a couple of years where you don't have much cheese or milk, then suddenly it will start happening even later in life.
Yeah. And one thing that drives me nuts is, for instance, I ran into someone who was militantly vegan on my secular talk server, and they're like, no other animals drink milk after their infants, but and just like going off on dairy products. And I'm like, here's the thing. We are omnivores. We have been omnivores since forever. Milk opened up a ton of nutritional benefits for us. It gave us a ton of calories that was fairly easy to get. So it makes sense that we would start to use milk too.
It's a huge evolutionary advantage. The same as
Yeah.
cooking, right? Like
Yeah.
cooking is great for health reasons because even though they didn't have any idea of what caused disease at the time, they were still killing the bacteria and parasites in their food and so suffered less. But also, cooking denatures proteins, which means it takes less energy to digest and extract the nutrients, which means in net total, we get about 30% more calories from eating cooked food than raw food. And that's a lot of fucking calories. That's why we can power such big, expensive brains and why we can get away with eating so little relative to our body mass compared to other critters.
Yeah, and that's one thing that if I had a time machine, I would love to see how humans first developed cooking. Like, what actually happened. The best, like, hypothesis that I've heard is that there was probably like a campsite or something a wildfire swept through, so everybody ran, and when they went back to go get their stuff, their meat was cooked, and they're just like, well, there's nothing else here, so they ate. Like, that's when the like, this could have possibly happened, this might have been how we got it, and I'm just like, that's...
like lightning struck some certain area.
It's probably not lightning. We know primates
Thor was up in the sky.
Shit together.
No, starting the wildfire.
Yeah, you really only need something that makes sparks and something to strike it against. Like we use flint and steel. You could take an iron-rich rock and a piece of flint, bang it together, it makes sparks. After a fairly short period of time of banging these rocks together and making the pretty sparks, you're going to notice you can cause fire to happen. Maybe it'll take years, maybe even a few generations to figure out how to build and control fire. But once you can do that, you're going to do it because you can see better at night and shit. You can stay warm in colder weather. There's a bunch of advantages to fire on its own. So the banging rocks leads directly to the control of fire. So that's how we get that. And how do we get cooking? That's more hypothetical. But
exactly.
You can see a bunch of different ways. Like, for example, your food is wet. So you put it by the fire to dry it because that's a known effect of fire, and it also cooks while it's drying.
That's why personally, like, I think it was probably like an accident with something to do with wildfire or somebody tripped or something, because your food, especially then, is so valuable. You are not going to put it into something that you think is going to destroy it if you desperately need it. So that's why.
Have you met humans? We throw all kinds of shit in fires today just to see what happens.
Well, yeah, that's true.
No, developing.
Yeah, but it's interesting to think about
how to do it properly. Like, taking an animal and spitting it and roast it. That would take a while to develop with intention. But it's easy to envision the possible steps. But cooking isn't the only cool thing we do. We also, whoops, this is the wrong one. Resist Oppression says, I do fluid dynamics for a living. I have enough of an understanding that is definitely on par. Mr. Blitz is a physicist I talk to on the regular, which is cool. We stand Dr. Blitz. He's a lot of fun. His debates, he's not just a typical debate, bro. He brings physics into it, and that's tons of fun. But the fluid dynamics reminds me that if all this studying of the universe and other wonders is for thirsty work for you, then maybe you should hydrate. Hey folks, I've been working hard on my health, and so far I've lost over 140 pounds. A huge part of good health is hydration. That's why I'm thrilled to partner with Epic Water Filters. Check this out. Not only can you say goodbye to expensive bottled water, but these filters are made in the US, so no tariffs, and they're made to fit your life. From these lovely pitchers I can fill from, to sink units, to portable filters that fit in your reusable bottle. With Epic, I can refill from nature's water sources and not have to worry about bacteria and whatnot. But also, send back a used filter to be responsibly recycled, and they'll send you a free replacement, saving you and the earth even more. Want to save a ton of money, be healthier, and build a better world? Head to epicwaterfilters.com and enter code EMBER15 at checkout for 15% off. Don't settle for random water. Upgrade to Epic. Now, obviously, drink random water if that's all you have. But, like, if you can filter it, it's safer and better. And a cool thing that I don't include in that ad is every water filter filters water, right? Epic's water filters are specifically designed to allow the nutrients, the minerals, the good stuff that you do want in your water, that you pay extra to get into your bottled water. It lets those pass, and it keeps the bacteria and the contaminants like lead and shit from old city pipes. It blocks those. So that's another plus too. And yeah, I have to try to. Some transitions are easier than others, but I have to try to get those in. One per show thing sort of deal. But yeah, they're a really cool.
I think you did good.
I literally do use it myself. This is the bottle with the filter in it. Like I use it myself. I really do. So yeah.
Did you notice that the water tastes different once you use the filter?
Oh yeah. Absolutely. City water is full of all kinds of unpleasant things, and you can taste it. In fact, there's a competition. I forget which magazine does it, but they do a competition where they will award a village or city or something with like the best tasting water of that year. And a couple of different villages around here have won over the past few years. Mexico, New York, which is just up the road from me, won it a couple of times. But here in my city, it's very city water flavored. It's almost like drinking out of a swimming pool. But with the filter, it tastes like clean water, which is really nice. It also makes
Mexico, New York
better. Yeah, Mexico, New York. It's north of Texas, if you could believe it.
Okay.
I am today years old.
So
it's like having Russia, Hawaii.
We have all kinds of weird shit here in New York.
What you make yourself? Oh, okay.
Yeah, we got some really we got some weird town names over here.
Yeah, Americans, our naming conventions are very peculiar. All right.
Next person I say that I hear call it Houston instead of Houston.
Oh, Houston?
Houston.
Houston sounds better.
That's a bit of a bone of contention because, again, from New York, in New York City, the street is called Houston because the man was named Houston and the city is named after him. So it should be pronounced Houston. But the locals call it Houston because Americans.
Just like technically,
it's not the only town like that.
My thing is you call people what they want to be called, and you call their place names what they call their place names. Like, if they say Houston, then it's Houston. It's not Houston. It's Houston.
There's a village in Maine named Peabody, for the doctor. Makes sense.
Yeah.
But the locals call it Peabody. Like, it's just consonants. It's Peabody. And if you say Peabody, they will look at you funny and have no idea what you're talking about. You have to say Peabody. We have around my area, there's a whole bunch of streets named Schuyler, but it's spelled Schuler. But if you say, where's Schuler Street, people look at you funny because they have no idea what you're talking about. Why they pronounce it Schuyler, I guess because for a long time people were illiterate and now it's stuck or something.
Here's a crazy
weird.
one. We have a town here in like the hill country of Texas. It's spelled grün, like as in green in German, but it's pronounced green. Even has the umlaut in and everything, but they just say green, and I'm just like, it's like the one area of Texas that has a bunch of, or used to have a bunch of German speakers. There's still some, but.
Right-handed Sith is originally from around my area, so he knows a bunch of these. We have another town, Pulaski versus Pulaski, named for the Polish general who helped in the wars and shit. But no, we're We're just going to call shit whatever we feel like. It's fine. Bree says the Quiver River in Missouri is pronounced Quiver by the people, the Folken, even though it's spelled like it should be the. I've been terrible at pronouncing things today. Like literally everyone has corrected me on everything. So I'm just going to say Sylvia because it sounds French-ish to me, but I'm just, oh my goodness. Okay. The naturalist's name was pronounced Cuvier, not Quiver. Cuvier. So I was in the neighborhood. I was closer than usual, but yeah, weird freaking names and shit. It's just, oh goodness. It's questions for your nonsensical multiverse.
Yeah, like if you look at Detroit, that's technically French. It's supposed to be pronounced Detroit.
That's right.
Damn
That's
French.
another one of our weird naming conventions. Iroquois. The Iroquois.
Exactly.
That was the French name for those people. And there's so many place names that have that in there.
Yeah.
The people call themselves Haudenosaunee, you know?
Yeah.
Yeah. Michigan has a lot of French names there. There's a lot of French names in Michigan.
Those damnable frogs. But we'll get to them another day. All right, so Slifer's meticulous spectroscopic measurements demonstrating the immense radial velocities of the spiral nebulae proved to be one of the most significant discoveries in modern astronomy. And that's really, really true. Like Hubble's discovery of distance would have proved Andromeda was a different galaxy, and the other galaxies similarly even further away. That would have, on its own, expanded our understanding of the cosmos from the limits of the Milky Way to the universe we now see. It would have been just as undescribably world-changing. Like, our knowledge of the cosmos expanded from 100,000 light years to almost 14 billion light years. That's an indescribable growth virtually overnight, scientifically speaking. That's crazy levels of more information than we'd ever it was literally mind-blowing at the time. But without Slifer's redshift data, we wouldn't have any idea what it means. So yeah, it's very cool shit. I really got to mark where I leave off by finally succeeding at getting the very difficult task of obtaining the faint Andromeda Nebula spectrum. And that is important. Cosmic Kyle, who may still be in the chat and was in the chat earlier, can attest to the fact that the Andromeda galaxy is so dim, you need to have a camera with a long exposure, often set up on an equatorial mount so it can follow the galaxy to get enough light from it. It's bigger than the Milky Way, but it's so fucking far. It's so very dim. You can really only see it through stupidly powerful telescopes or long exposure photographs. To get enough light to get a spectrum out of the damn thing, crazy accomplishment. But by doing it, he provided enough evidence that this nebula was much farther away than scientists had previously assumed. After perfecting his technique, he confirmed his results on Andromeda by measuring Doppler shifts in other spirals, although the implications of extremely large radial velocities for the spirals were that they could not be contained within the Milky Way. And that's especially true for the redshift ones, right? Because redshift means they're going away. If they're going away at 1,000,000 kilometers per second, they, even if they're inside the Milky Way right now, they won't be for long. Holy shit. And if the universe is only 6,000 years old, there's no way they could have started inside the Milky Way. So it just completely blows this idea that the Milky Way is all that there is. It just kills it dead instantly. So the island universe dispute between the major protagonists, Curtis and Shapley, retarded the acceptance of the significance of his discovery, which is why it took other data, like from Hubble and whatnot, to get the job done. Although Slifer's work on radial velocity was consistent with an extragalactic position for Andromeda and the other spirals, his findings did not prove the island universe theory on their own because they did not provide the distance to the spirals, which we needed from Hubble. Slipher also confirmed the spirals rotated. The discovery meant that though determining proper motion, apparent angular rates of motion of a star within the spirals, the distance to them might be obtained and the dispute settled conclusively. Agreeing on the procedure in principle, Van Manen's systematic error led to a mistaken interpretation indicating that the spirals showing considerable proper motion could not be any great distance, seemingly disproving the island universe idea. And so what this is talking about is Manen claimed to have measured the spirals of Andromeda, which, you know, you've seen the photos. And I can pull one up probably. Andromeda Galaxy. Bloop. And bloop. And Bigify and share this tab. All right, so this is just one, but you can see the spirals in the damn thing, even though it's kind of on edge. Some of them are better. M3 is a really good one, but whatever. You can see this. So Van Manen claimed to have measured the rotation as being roughly equivalent to planetary speeds, meaning this, he contended, rude freaking pop-ups, was a forming stellar system, a local star system that was still forming. This was a proto-star in the center, and these different dusty lanes, the gaps were where planets were forming and scooping up the dust. That's what his contention was. And since he claimed to be able to measure the rotation as being consistent with a stellar system, then it's dim because the sun there hasn't turned on quite yet. It's still working on it. And that threw things off for a while because this motherfucker fudged his data. So that's what was going on there. But in 1924, Hubble discovered Cepheid variables. He derived the distance of 490,000 light years. Light years! Light goes a long way in a year, folks. A long fucking way. To put it in perspective, the Voyager probes, they've been going. Fastest fucking thing humans have ever launched. They've been going since the 1970s. They are just now, 65 years later, approaching 1 light day out from Earth. And they are fast. They are so stupidly fast. And they're just now reaching the distance it takes light to go 1 day. We're talking light years. It's an indescribable amount of fucking distance. Well, it's describable. We call it a light year, but still.
Can I give one of my favorite space facts real quick, since we're talking about distance? Sure. Biggest black hole in the universe is 1 light year in radius. It would take, or it's not light year, sorry, light week. It would take an entire week to fall to the center. Ton 618.
Okay, I was just looking it up because I'm like, it sounds like you're talking about Ton 618, which is not actually the largest. It's the largest that we have confirmed data for.
Yeah, that's what I'm going with confirmed.
They're definitely bigger. We just don't know their exact size.
Yeah, that's what I'm going with confirmed, because that's like, we know how big that is because we know the mass of it, which black holes, their mass directly dictates how big they are.
Yeah,
so,
the Schwarzschild radius. Now, when we think of big, we're talking about the event horizon. Like the singularity itself is just a singularity, but the event horizon is effectively the point of no return. The reason they're black is because that's where gravity is so steeply slanted, it exceeds the speed of light to get back out, which is why light can't get back out, because it doesn't go fast enough to get up that gravitational gradient. It keeps getting bent back inwards.
Yeah,
that's what those are. So that's not the black hole itself. That's just the point of no return. However, humans cannot get that close because we cannot go anything close to the speed of light. We could be quite some distance from the event horizon, and for us, it's still beyond the point of no return. We're gonna fall in because we can't get away. So be careful when you're traveling near black holes.
That's one thing that I love about black holes. Like, once we actually get, or if we ever get like interstellar travel, a black hole is not going to bother you unless you are looking for trouble. like they just stay there. Their realm of influence is pretty small. If the sun were to suddenly turn into a black hole, it'd be about 3 kilometers in radius. Like that's tiny. The Earth would be less than a centimeter if it was just turned into a black hole. But yeah, it's like you have to be looking for trouble to get in trouble with a black hole. You have to get so damn close to it.
The main issue is as a navigational hazard, because they do bend space the same way every other massive body does. And we know from like the interstellar objects like Atlas 3I that came through the solar system, our sun is heavy enough that it will move the course of interstellar objects. Now, the good news is with stars, you can fucking see them. They're very bright. So like, hey, there's a star. Let's be careful not to let it fuck up our course. But a black hole, unless it's actively feeding, you can't see the damn thing. So you could be zipping along on your course to Alpha Centauri, and you wake up from your sleep of 400 years or whatever, and you're in fucking Epsilon Eridani. And you're like, how the fuck did I get here? It's because you passed near a black hole and it warped your course and sent you off this way.
Yeah, but I'm willing to say if we've gotten to that point, one, we probably do have a way to detect them, or at least have the computers detect them and adjust accordingly. And two, black holes are pretty rare. There's not a lot of stars that become a black hole. Like, I think the closest one is like, there's one that was, last I saw, 1,700 light years away, and I think there's another one that's a little bit closer. But yeah, they're not like running through our solar system all the time or anything.
That we've noticed. Because again, they do have the mass of a regular object. Like if a centimeter-sized black hole came through, it would be effectively the equivalent mass of Earth, because the mass determines the Schwarzschild radius. So centimeter-sized black hole passes through, it's got the mass of Earth. Jupiter's not going to notice an Earth zipping past it, but Earth will notice an Earth zipping past it.
Oh,
we'll have all the earthquakes.
All of them. Might
lose them. Can I become a black hole because I never got to be a star?
Hey, black holes are awesome.
Absolutely. It's fun shit. Oh, goodness. All right, folks, we are just about out of time. I want to get a little bit more of this story out here, and then we'll do our wrap-up thing. Reminder, if you're just joining us now, we're here every weekday at 11 a.m. Eastern time. Do the calculation for your own time zone as applicable. We're doing the secular accomplishments of science all month, leading up to the holy day post solstice, by whatever name you call it. So we've got geology, we've got a Bible verse to reflect upon, and we've got a secular accomplishment. And I think it's going to be a lot of fun. Thank you for joining us for this one. Make sure you join us for the future ones. It'll be so cool. Speaking of things that are so cool, the Detroit Atheist Queen 24/7, which incidentally is a channel you can subscribe to also. That's Kelly's channel. Kelly says it's $5, and thank you, and says towards Embers Sammy, because I do love sandwiches. I really do. They're one of the best human accomplishments. That's how we're going to win over aliens, by the way. When the aliens ever show up, it's not going to be fusion. It's not going to be lasers. They know all this shit. This is just physics. It's going to be the weird shit we've come up with that they never have, like sausages. Sausages are going to be the thing we trade with the other civilizations in the galaxy, because it's a weird thing that isn't inevitable from science that humans have come up with.
There's this deli with this butcher that makes he got the onions and the peppers, everything already, and those are like perfect on the grill. This is delicious. I'm getting hungry now. I got to go to that butcher.
Stop it!
Get that. Oh man, it's different. It's just everything all in one. You don't have to worry about add nothing. Just bite the sauce in. Onions and peppers.
Come here for the tangents, but also come here for a good time. And if you're here for a good time, we have a shirt for that too. Can I make it a little? Well, that's not what I wanted to do, but hopefully you can see it a little bit better. If you want to good time. And there's garlic bread, because everybody loves garlic bread. It is also one of the greatest human accomplishments of all time. But that's also ace jokes, but we don't have time to get into that right now. Jokes are funnier when you explain them, but we don't have time to go into that right now. You can find that and all the other cool stuff that we've got here at the store. We have a store. Sometimes it shows up underneath these videos on YouTube, but you can always find it, all the items, at the shop on betterthanember.com. That's where you can find all my links, where you can find the links to every other cool creator I know about, including these two. You can find information about gender science, intersex science, countering religious apologist creationists specifically, because debunking conspiracy theories is a big part of what we do here. There's a whole bunch of stuff on the website. But yeah, the shop is there too, among other things. Deviant Outcast sends us 100 sex, which is the antidote to garlic bread, by the way. Thank you, Deviant. And says, to Ember for making Soot happy with her wonderful laugh. He tried to tickle you on the screen earlier just to get you to laugh. If that worked, I would never get to say anything else. I'd be like the Pillsbury dough lady. Like, you touch your screen and they go something like that. I don't know. It's wild. All right, I got to do that. We're already going into overtime, so I got to do this quick. Let's see. Right. 1924, Hubble discovered Cepheid variables and derived a distance of 490,000 light years for the galaxy. The distance is far beyond the farthest globular clusters of the outer limits of the Milky Way. The estimate has now been revised for Andromeda to be 2.2 million light years. So Hubble was wrong. It's 4 times further away than he thought, and change. Although his distance determinations might have settled the problem in 1925, doubts still lingered because Hubble's conclusions were based on the controversial period luminosity law, and because of Van Manen's contradictory results, which somehow were exceptionally consistent. The problem was not resolved until 1935, when a new set of measurements indicating that Van Manen was incorrect. The most all-encompassing result from Slipher's work on the spirals was the preparation that he made for investigations of the motion of galaxies and for the cosmological theories based on an expanding universe. By 1928, Slipher's measurements of the radial velocities of more than 40 galaxies indicated that most galaxies were moving away from the Milky Way. At about the same time, Hubble had noted that more distant galaxies had greater radial velocities. In fact, because Hubble's getting the distance while Slipher's getting the velocities. In fact, there seemed to be a direct relationship between velocity and distance. This relationship, today known as Hubble's law, with a number connecting distance and velocity we call the Hubble constant, indicates the universe is expanding based on Slipher's measurements as well as Hubble's, that showed almost all the spiral nebulae, the spiral galaxies, are moving away from the Milky Way as well as from each other with very large velocities. These observations suggest not only that the spirals were galaxies like the Milky Way, but also that the entire universe was expanding. And that is fucking cool, because even without Einstein, we still would come to a modern understanding of an expanding universe. And that's a hell of an accomplishment.
Yeah.
Which is why I wanted to start our Advent with it, because you have to begin at the beginning. If you want to make an apple pie from scratch, you must first create the universe. That's a Carl Sagan quote, if you're not aware.
I'm not aware of that. I am now, though.
Carl Sagan's the best. Oh, goodness. All right. Thanks to everybody who sent super chats. I very, very much appreciate those. Lil opened the show with $5 saying Christians have the Big Bang Theory too. God said it, then bang, it happened. All hail ex nihilo. Kelly sent $5. Thank you, Kelly. Towards Ember Sammy. I'm going to go have lunch immediately after this. We've been talking about food all fucking day. But anyway, and Deviant sent us 100 sex to Ember for making Soot happy with her wonderful laugh. He tried to tickle you on the screen earlier just to get you to laugh. It's worth a try. It sure doesn't hurt. Thanks to all of you for being here. As I didn't get to as many chats as I usually do because we were trying to do the thing. But I do appreciate y'all being here. Having you here, getting your input, that's the reason we do lives. And so thank you all so much for coming. Remember, join us tomorrow, 11 a.m. Eastern, for day 2 of Atheist Advent. Until then, I have new credits. I just did the credits for November, so it's in a different place, and I had to find it. Anyway, mwah, love you all. Toodles.
Bye.
Thanks to all our patrons and top-level members for November. Miranda, Karen Butcher, Jessica the Trans Metal Alchemist, Robin Webster, Maya Adkisson, Jimmy Tux, Ian Chen, Lilith, Ember Lynn, The Barely Bearable Atheist, Eric Wander, Jason Jacoby, Godless Engineer, Jester, Lil of All Trades, Deviant Outcast, Kelly King, the Detroit Atheist Queen, The Mighty Filbert, and Secular Phalanist. And you can add your name here next month by signing up at patreon.com/betterthanember, or by joining Emberships here on YouTube at the Cinder level, which also includes all the custom emojis, tons of member-exclusive content, member-only live streams, and a bunch of other stuff. I deeply appreciate all the supporters who keep this channel going. Thank you all so much. Because of you, we're building a wonderful community that I'm very proud of.
Just like a spark that's breaking out. Can't make a stop, can't turn back now.